All right, so we're gonna find the 10th term of a geometric sequence. The first one we have here is the sequence 1600, 800, 400, 200, and so forth. So for these, I usually will apply this formula for the nth term of a geometric sequence where an equals am times the common ratio r to the n minus m power. Now, with this equation, it's going to be pretty easy to find the nth term as long as you know the common ratio. So to find the common ratio, if you can't see it, obviously if it's something that's pretty simple to just see that you're multiplying by 2 or dividing by 2, then obviously don't waste your time. But in this case, let's pretend that you can't really see that you're dividing by 2 or multiplying by 1/2. So what you would do is just take two consecutive terms backwards and divide them. So we would go like 800 over 1600, or you can go like 400 over 800, which is going to be the same as 200 over 400. It's going to be the same common ratio, which is going to be 1/2. Then we use this in place of r. We're trying to find the 10th term, so we're going to have a10 equals am times 1/2 times 10 minus m. Now, I like using am instead of a1 because this gives you the freedom to pick any term you want. Because sometimes you won't have a1, so then you won't have to spend extra time finding a1. So for example, if we just did a1, we would just put 1600, but you can also put, let's say, a4. So let's just use that just so I give you an example of what I mean. Let's use the fourth term. So then this would be 1/2 to the 10 minus 4 power. A4, we replace it with 200. And then your exponent is just to the 6. Also, when you have a higher number for m, you won't have to have such a large exponent. But in any case, it'll still give you the same answer. So 1/2 to the 6, 1 to the 6 is 1, 2 to the 6, 2, 4, 8, 16, 32, 64. We'll have 200 over 64. And you can break that down into, I think, like decimal or a little more than 3. Yeah, 3.125. Only leave your answer in a decimal if it's exact. In other words, don't leave like an approximation. Like if you had something like the square root of 7, that this is a rational number. So you want to leave your answer square root of 7 and not like this crazy decimal. Let's look at another one. So number 6, we have 0.000000060 zeros, 0.000004 zeros, and then 2 zeros, and then no zeros. We still have to find a10 here. So find the r value by, again, let me put this in red, by just dividing two terms that are consecutive backwards. We'll go 0.1 over 0.001. It's easy to see that's 100. And so we use our same equation for the 10th term. A10 will be, and let's just go, again, let's go with A4 again, because that's probably an easier number to work with than this. Let's go A4 for AM times our common ratio, which is 100, to the 10 minus 4 power. A 4 is 0.1. To the 6. Let's see if you can understand what this notation is. See, we have 100 raised to the 6th power. Now, like, that's a big number. This is basically 100, or this is basically 1 times 10 to the 12th power. But let's go ahead, let's multiply this by 0.1, so we can just write one final answer. This is 1 times 10 to the 11th power. So this would be like this, 1 times 10 to the 11th. Which is going to be a 1 followed by 11 zeros. 10 to the 1 is, that's just like 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so that looks like going to be 100 billion. This is where, so again, and it's going to be common to have to use or scientific form when you're dealing with geometric growth, because things can get very, very small and very, very big. Let's do a couple more. Number 7. We got negative 64, 96, negative 144, and 216. And again, try to, maybe try these on your own first if you think you're getting the hang, and then check in to see if you're doing this correctly. So maybe pause the video, try them, and then unpause it to see how you're doing. But of course, I'm just going to keep on going. So find the common ratio first. Here, I'll take 96 over 64 because those are probably easier numbers to work with. Or 96 over negative 64, which is going to be 1.5. I'm going to leave it as 3 halves, or negative 3 halves. It's actually easy or better to use fractions in dealing with geometric series. And so then we're going to find A10. And in this case, I'm going to use A1 times R, so times negative 3 halves, to the n, or 10 minus 1 power in this case. A1 is negative 64 times negative 3 halves to the 9th. We're going to have negative 3 to the 9th. So we know it's going to be a negative number. So 3 to the 9th will be 19,683 over 2 to the 9th power over 512. Simplifying this, we can cancel out, we can reduce the 64 over the 512 because they both go into 64, or 64 goes into both of them. So then this ends up being positive 19,683 over 8. But you can leave it like that, or you can write it as this decimal. Either case is fine. I don't know why I put there. I should have put 8. Whoops. 8. So it'll be 2000 or 2,460.375. And that is an 8. And let's just do one more for now. 2, -6, 18, -54. Common ratio will be -6/2, or we're just going to get -3. Using our equation again, A10. Let's make it A1 times -3 to the 10 minus 1 power. A1 is 2. This one looks like it'll be the easiest. -3 to the 9th. 3 to the 9th will be 19,683. It's going to be negative since we have an odd power. Times 2. And we'll get negative 39,366. All right, I hope that helps. Again, any feedback is always welcome, and I'll see you guys in the next video.